Okay, problem number 33. Building shadow. On a morning of a day when the sun will pass directly overhead, so the sun is going in this direction, right? The shadow of an 80-foot building on level ground is 60 feet long. Okay, so here's the shadow, here's the height. And as the sun moves this way, the shadow will move this way. The angle the sun makes with the ground is increasing at a rate of 27 degrees per minute. Okay. So we have d theta dt is equal to, it's increasing, so it's positive 27 degrees per minute. Okay, what is the rate of the shadow? At what rate is the shadow length decreasing? Okay. Okay, so we'll call this x, call this y. Okay, at what rate is the shadow length decreasing? Okay. And so we're looking for what is dx over dt. Okay, so I have theta, I have x, and we have y. So I'm thinking opposite, and adjacent. Opposite adjacent is going to be tangent. So let's use tangent, separate problem. So tangent of theta is equal to opposite over adjacent, and that's gonna be tangent of theta equals to opposite y over x. The building itself is not going to shrink at all, so we'll call that as our constant. So tangent of theta is equal to 80 over x. X will be shrinking, will be moving forward, as well as d theta is going to be increasing, moving up. Okay, we can take the derivative of this because we want d theta dt and dx dt, so relationship to time. So the derivative of tangent is secant squared theta, chain rule, d theta over dt, equals to, you can rewrite this as 1 over x times 80. So constant is 80, and the derivative of 80x to negative 1 power. Let's give us negative 1 over x squared, and then dx over dt. We know what, okay, let's figure out the variables. Secant squared theta. Secant squared theta is hypotenuse over adjacent. We don't know what our hypotenuse is, so we would have to find it. This is 6/8. This 36/9, remember? No, sorry, Pythagorean triple. So our basic Pythagorean triple would be 3, 4, 5. If we multiply each of those by 20, this would end up with 60, 80, 100. So that's going to be the secant of theta is, that's 100 feet here. Secant of theta is equal to 100 over 60 feet. So we're going to replace that. So back here, so secant squared theta is 100 over 60 squared. D theta dt we know is decreasing at a rate of 0.27 is equal to negative 80 times 1 over x squared. We know x is 60, so 60 squared. And then we're looking for dx over dt. So now the problem reminded us to change our this value right here from degrees to radians. So if you guys remember, the conversion is going to be 0.27, and this is degrees. Sorry. Let's write degrees per minute. And we need to change this into radians. So we change this into pi radians over 180 degrees. That's a conversion. And this plays out calculator-wise to be 0.0047, and that would be radians per minute. So we're going to plug that back into this value right here. So writing it out is going to be we're going to square our 100, square our 60. Actually, we're going to leave the 60 alone because we're going to end up having a 60 squared anyways. As you can see on the other side here. I'm going to change this to, we'll write 0.0047. We're going to change that into a fraction. Make the calculation a little bit easier. So we're going to move some decimal points over. Change that into, we had 4 decimal places. 4 decimal places. So 1, 2, 3, 4, and as you can tell, these guys here are gonna divide out. Be a little cleaner. We're gonna move the values on the right side over. So it'll be 60 squared on top and 80 on the bottom. And then we're gonna move that negative to the front. This equals to dx over dt. Okay. Get rid of 60 squared. These go away. And we're at negative 47 over 80. And we're looking, this is in feet per minute. And the problem asks us specifically here, express it in inches. Right, see that? So we're going to go ahead and multiply our negative 47 over 80 feet per minute. And our conversions are going to change it to 1 foot for every 12 inches. So multiply that by 12. So you can reduce if you want some more. So it'll be 6 times, divided by 4. So it's 3 times, this is 3 left. This is 20. So 120, 141, negative 141 over 20 inches per feet. Inches per minute. And this gives you approximately negative 7.065 inches per minute. And that's it. There we go.